Hey everyone, Dylan here. I wanted to show you guys how to think about and solve the LeetCode problem 21, which is merge two sorted lists. So let's read the problem to understand what LeetCode is asking from us. You're given the heads of two sorted linked lists, list 1 and list 2, and being sorted is important. Merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists and then returning the head of the new merged list. And so here they give us 1, 2, 4, and 1, 3, 4, and then we should return 1, 1, 2, 3, 4, 4. So we're basically going back and forth to essentially check, is this value less than this value? Is this value less than this value? And so intuitively, if we had two arrays, you basically just loop through both of them and check, is index 1 and j, less than? If so, take I or j, add it to your array, and then kind of just keep moving forward and like a two-pointer approach. We're basically going to do the exact same thing. And so how I like to do it to skip like a bunch of conditional problems, we have a new list here. And so what we would want to do is create a dummy node, where the dummy node essentially is just a null node. And then we also need to create a tail. And the tail is going to be our second pointer essentially, which we're going to move down our list. And the t is just going to point to the dummy node. And so we need a loop which then checks these values, and these values. So we'll have a while list 1 is not null, and list 2 is not null. We need to check if list 1 is less than list 2. We'll then add list 1 to our new list, and then else, since now we know that list 1 was greater than list 2, we'll take our list 2 and add that to our new linked list here, which we can do by instead of dummy, we're going to do tail.next. And we do the exact same thing up here as well. So I should move this down a little bit, this down. Yeah, here we go. So our tail will then point to list 1. And then if you worked with linked list, we need to also move list 1 to then the next spot, which will be list 1 dot next. And the same thing that we're doing here is also going to happen here. Let's move this over. And so then this, I feel like deleting it is going to take me too long. But we're essentially just taking the list 2, removing this guy. And then the same thing for this will also be list 2.next. And so what we end up doing here is we think about it, is 1 less than 1? It's not, so then take list 2's 1 and move this guy to our new list down here. Actually, an easier way to do this. I apologize. I'm trying to figure this thing out. we'll go here. So we have our new list down here. And so is one less than 1? It's not, so then we fall into this statement here. So then we take the list 2, 1, and then point to here. But now we still have our list 1 pointer here and our list pointer here too, our list 2 pointer there. And then we check, is list 1 less than list 3? Oh, it is. So then this code hits. And then we move the list 1 element here to our dummy node here, where we're moving tail. So right now, tail, after running this code here, is pointing to the end, which is why we call it the tail. And then is 2 less than 3, as we loop through here, sends 2, and then 3 as we're moving our pointers and the conditional statements. Yes. Remove 2. Now we have 2. And then executing the code, which we actually didn't implement. But we'll have the tail and we'll move it to, tail.next. And that's what's moving this. So then our tail points to 2. Cool. Is 3 now less than 4? It is. So then add 3. Remove 3 here. And now we have 4. Is 4 less than 4? It's not. So then this code executes, and then we add 4. And so then we still have, the 4 up here still remaining. So then we actually need a little bit more code, because now our list 2 is null. We exit out of the loop. And so then when we do that, I'm just going to delete all of this. We actually will end up taking whatever is the remaining value in the list and essentially just appending it to the end of our new list. And so that'll kind of look like if list 1, is not null, then take the tail.next and just point it to list 1. Otherwise, take list 2 and just point, and then just have tail.next point to whatever the remaining value is there. So let's go implement this in code, since my design was disgusting, I think. You guys can let me know in the comments. So we'll let dummy equals new list node. And then we want to set up our tail, so let tail point to our dummy. Then while list 1 is not equal to null, and list 2 is not equal to null, we need to then check if list 1's value, which is, the number that we're actually doing the comparison on, is less than list 2's value, then tail.next will equal list 1, and then we'll take our list 1 pointer and move it to the next value. So then we just essentially, with this code, if we removed 1, we then need to move the pointer for list 1 to 2. Else, tail.next can point to list 2, because we know list 2 is actually less than list 1, and then list 2 will need to then get moved up. Otherwise, we're just pointing to nothing. So then remove this and then move to 3. And then we do the 1 is less than 3. 1 will get added. Is 2 less than 3? 2 will get added. So on and so forth. And then we also need a way to keep moving our tail. So within the loop, after these conditionals, tail will equal tail.next. So same way that we, kind of move through the other linked list, we need to move through our own linked list that we're creating. Then, once we do all this, we're going to have the remaining value. So then we need to check tail.next. Actually, I'm just going to do it like a normal conditional block. So if list 1 is not equal to null, tail.next will equal whatever list 1 is, whatever the remaining. There could be 32 nodes here. We're just going to take the remaining of the list and just append it to the end. or is it prepend? We just add it to the end of our list. Else tail.next will equal list2. So if list1 is null, or is not null, add it to the end. If it is null, then take list2 and add to the end. And we already did our kind of checkup here to make sure that once we get it to one of these values to null, we'll add one of them. And then instead of returning, I don't know why I said reverting, instead of returning our tail, because right now we are only moving the tail here. So tail is currently pointed to this node. Even if we do this right here, we set up tail's next node next to point to this node here, but tail is still here. So if we return tail right now, I believe it'll be 4 and 4, which, we can return tail just to see what it looks like. I could be wrong, but I expect it to be 4, 4 for this test case. Yeah, 4, 4, because tail's pointed here, and then its next is here. So if we return tail.next, it's going to just be 4, which I'll do just for all intended purposes of learning. See, and then we just get 4. So what we do know, though, is that dummy is still that, the beginning of the list, but we don't want to return dummy because it points to nothing. We want to return dummy's next, which points to 1. So if we return dummy.next, which is actually our head, it should point to 1 and return 1, 1, 2, 3, 4, 4. So we have it here. And then we can just kind of submit and see what we get. It's 100%. What I was going to do before this was I was just going to make this a ternary operator. So tail.next equals to, and then if list1 doesn't equal null, return list1, else return list2. This way, we're going to store whatever value that this conditional statement returns. So if list1 is not null, take list1, add it to the tail.next, or list2, add it to the tail.next. But yeah, I appreciate everyone who has kind of stayed here and watched. If anyone has any questions or feedbacks, I would love to hear it. I'd be happy to help. I know there's a bunch of these problems on YouTube. I just kind of want to put my own words out there for explanation. I'm hoping my diagrams and everything gets better. But yeah, thanks for tuning in. I hope you guys learned something. Later.